All right, this video is on polyatomic ions, which is the next step in our naming of ionic compounds. So first thing, right, let's break down the word polyatomic and ions. We know what ions are. Those are charged particles or charged atoms. You know, it's like chloride and fluoride and magnesium ion and aluminum ion, right? And then polyatomic, right? Poly meaning many, and then atomic meaning atom. So what we have here is a polyatomic ion is a charged particle made up of many different atoms. Now, first and foremost, you are not going to be responsible for memorizing these ions. Now, there are going to be a handful of them that I'm expecting you to know, and if you're going, well, knowing and memorizing, they're exactly the same thing, and no, they're not, okay? I'm not expecting you to remember what the chlorate ion versus the chloride ion is, okay, which is these guys right here. But as far as which ones I am going to want you to know are the ones that I'm going to be using a lot, all right? One of them is the only cation we have on this table, which is the ammonium ion, okay, NH4+. So when you hear things like ammonium chloride or ammonium nitrate and so on and so forth, that's what the ammonium is. Ammonium is NH4+. All right? Some other important polyatomic ions that we'll be seeing a lot: nitrate, sulfate. Okay, we have let's see, moving down here, hydroxide. Okay, phosphate. All right, these are the big ones. Let's see, carbonate, bicarbonate, which is also known as hydrogen carbonate, but this is the more common use, right? Bicarbonate, for example, sodium bicarbonate is baking soda. Okay, acetate. Let's see here, peroxide. Any other ones are gonna stand out for me? 1, 2, 3, 4, 5, 6, 7, 8, 9. Just since I want it to be nice and even, we'll go ahead and throw one more out there. Let's go with permanganate, just because I like the word. Okay. Now that doesn't mean that I'm not going to ask you questions about these other polyatomic ions. It's just these are the ones that we're going to use the most. So let's go ahead and break into some examples. But first I want to mention one more, okay, because I mentioned in the previous video, is the mercury 1 ion, which is Hg2 2+. Okay, so the mercury 2 ion, right? Mercury, it says mercury, it's the mercury 1 ion, but it's a polyatomic ion because there's more than one mercury atom involved in making this ion. And how about this? Because I want to, I added 1 to make it 10, I'm going to go ahead and take 1 away to keep it at 10, and I'm going to go ahead and take permanganate back off. All right, so we're going to deal with the mercury 1 ion on occasion. All right, so now let's get into some example problems. So if I was to have, let's pick a nice simple one, lithium. Let's go lithium nitrate, right? Well, if I look back in, like I said, right now you guys haven't used this a lot, and you won't be using it a lot for, or you'll be using it a lot, but you're not going to be expected to know it right offhand. A lot of those 10 amino acids, those 10 polyatomic ions, I'll probably give you on this test, all right, or at least give you the ones that matter. But I'm not going to, later on, you'll kind of be expected to know what nitrate is because we're going to be using it so much. Okay, so let's go and take lithium. Right? Now I know lithium is an alkali metal, therefore it has 1 valence electron, and it's going to form a positive 1 charge. And then I also know that nitrate, based on that table, is NO3 minus. Here's the important thing. You need to treat this whole thing as if it was one ion, because that's how, or at least one substance, because that's how it behaves. It travels together, that NO3, those four atoms travel as one. So if I was to draw lithium nitrate, it would be Li, since it's the cation, NO3. And that's lithium nitrate. Okay? Take a look at a different one here. Maybe one a little more complex. We'll go with calcium. Calcium hydroxide. Okay? Calcium, oops, I can spell. Calcium, close enough, hydroxide. Okay? Well, I know calcium is an alkali earth metal, which means it's going to be Ca2 plus. And I know hydroxide is OH minus based on the table. Now, here's the thing. Normally, if it's an OA, or if it's a negatively charged and I have a -1, and then my calcium is a +2, or my cation is a +2, I would need to have two of these, right? Two of these whole things in order to make it neutral, right? Because I have 1, 2 plus, plus 2, 1 minus, to equal 0, right? I need to have that happen because I need my common, or my final compound to be neutral. Now, here's a tricky thing when it comes to polyatomic ions. Because you treat them as one entity, you have to distribute them accordingly in your formula. So, for example, if I was to do this, CaOH2, this would not be the proper way to write calcium hydroxide. And the reason is because each hydroxide has an oxygen and a hydrogen, which means if I have two of those, I need to have two hydroxides. According to this, it looks like I have a calcium, an oxygen, and two hydrogens. So to remedy this, instead of writing CaOH2, I go Ca parenthesis OH parenthesis 2. Okay, which means I have two of those hydroxide polyatomic ions in this ionic formula, or ionic compound. Okay? So, let's do a couple more. How about this? Ammonium chloride. Okay? Like I go NH4 for my ammonia, it's +1. Chloride is -1, right? So if I was to bring ammonium chloride together, this is a pretty easy one. This is just going to be NH4Cl. Now, I am not going to do parentheses here, okay? Because I only need one. I only need one ammonium. I only need one of the polyatomic ions. If I had, for some reason, instead of a chloride, I had an oxide, right? Aluminum or ammonium oxide. Well, I know that oxygen, the oxygen ion, is -2. That means I would need two of my positive charges in order to match up with those two negative charges to equal 0. So if I was to make ammonium oxide, there's my two ammonias that would go with it, and then my oxygen. That would be ammonium oxide. Okay, we'll do one more. We'll go ahead and stick with ammonia this time, or ammonium. That's one thing that a lot of people get kind of confused. Ammonia is NH3. That's the what's in Windex and stuff like that. Ammonium is the NH4 plus ion. But let's go and say ammonium phosphate. Okay? So looking at that table, ammonium, right? Phosphate. And like I said, look at that table. Use it. Okay, it's in your book. So ammonium phosphate, I have one positive on the ammonium side. I have three negatives on the phosphate side, which means I need three ammoniums to counteract the one phosphate to make it 0. So I have parenthesis NH4 3PO4, ammonium phosphate. All right, let's try naming. Okay, let's try naming. How about, let's see here. Oops, that's an eraser. See if we can name that. Okay, so this is hopefully recognized as the carbonate ion. All right, that's the carbonate ion. And then this is potassium. And remember, we don't have any special name for the cations in this case. So this answer, or the answer to this question is, what's the name? It's potassium carbonate, would be K2CO3. All right. Another one. How about aluminum sulfate? Okay. No, I don't want to do that because I just told you the name. Okay, so I got to think of something different now. Okay, try that one out. So hopefully we see that because this is in a parenthesis, we know that this is a polyatomic ion. That is the nitrate ion. This is magnesium. Okay, so real simple. That compound is magnesium nitrate. All right. Now these have all been type 1 cations. Let's try something different. Let's try something with a type 2 cation. All right. How about, what is this guy? Let's try this one. Ah. All right. What's that guy? Well, here I know that this is hydroxide. And I know that hydroxide is a -1 charge. That's going to be important because this is copper. Copper is a transition metal. It can be one of two, in this case, many one of two charges. It can be either copper 2 or it can be copper 1, right? Based on what we've seen with copper. Well, looking here, I see one copper. Okay, real quick. I see one copper and I see one hydroxide. Well, if the hydroxide is -1, which one of these two do you think is the appropriate copper? And of course, that would be copper 1. So this would be copper 1 hydroxide. Okay? Next one I'm going to do is right off of your worksheet. Here we have okay, let's see if we can name that bad boy. So hopefully we jump this out and say, okay, that's chloride. And like I said, I know -1 for chlorine, right? And I know it took 2 of them since I have a 2 right here, right? So looking here, this is mercury. Oops. That is mercury. But there's 2 types of ions there. We have the mercury 1, right, which is Hg2, 2+. Remember, this is the mercury 1 ion, but it's a positive. It always exists as a polyatomic. It exists as 2+. Okay, or we have mercury 2, right, which is going to be Hg 2+, just as is. Okay, there's mercury 2. So the question is, which one of these is going to be the proper name? Is it going to be mercury 1 or is it going to be mercury 2? Okay, so take a minute to ponder that. Okay, hopefully we didn't get too tripped up on this. This one is pretty tricky, right? This right here is mercury 1, okay? Mercury 1 chloride. And the reason why it's mercury 1 is because if you look, Hg2 gives this away, right? That's mercury 2. If I have Hg2, then that would be that kind of gives it away as the mercury 1 ion. And the other reason why is if I know that it took 2 chlorides in order to cancel out this 2 positive charge, that just reaffirms that it is mercury 1 chloride. Okay, this one's a little tricky, and we'll get some time on it, and I'll explain it again if we need to in class. But just a quick overview, right, is so a little flow chart for you. A binary compound, meaning it's made up of 2 atoms, only 2 different elements. Well, if it's a yes, then you're doing the same thing that you've been doing before this lesson. Now, if you look here and it's a no, and you notice that there is one of the polyatomic ions present, then you're going to be applying the rules that we did in this video. Okay? If there is no polyatomic ion yet, well, we'll get to that when we're done with ionic compounds, which is going to eventually bring us to covalent compounds, right? And we'll talk about how, well, A, what those look like, and 2, how to name them in the next lesson.